Selvin, check one.
There we go.
All right, there we go. Let's open that up. You know who I am, Mark Marquette. We know you're staying curious. And this is Mr. Kevin Brown with us beside us here. Kevin,
Afternoon.
Good afternoon.
Happy
Good
to be
to
here.
meet you. Selvin, put our little banner up the top up there so everyone knows it's American Space Museum, and stay curious as Kevin's friends and family from around the world are going to be wanting to watch
Oh yeah,
this
I'm sure
on
they're
there.
just piling on.
That's right. That's right. Glad to meet Kevin. Kevin was part of our Shuttle Fest 2 weeks ago, and he is a vice president at All Points and slash Space Prep, I say. All Points is a company you probably don't know much about, but they have a lot to do with what's going on at Kennedy Space Center. Kevin, welcome.
Thank you very much. I appreciate the opportunity to be here.
Well, you're going to talk about something that when you mentioned it, I said, I got to have you talk about this DC-X experimental Delta Clipper that was 30 years ago. This is exactly what Elon Musk is doing today.
It's 30 years.
And you're going to tell us about it. You were a teenager, obviously, when you worked on that.
Sure I
back in
was.
the day. That's right. Time certainly flies when you think the 90s are 30 years ago.
It
Right?
does indeed.
In there. But Kevin, it's great to make your acquaintance and your friendship, and you discovered our museum. And tell us a little bit about yourself. Where'd you grow up, and how'd you get hooked on space?
Oh, sure thing. Oh, and I also tell you that it's a little crazy when you talk about a 30-year time frame to have a daughter that's almost 30.
Yeah.
Time does fly.
Yeah,
for
mine's
sure.
27. I understand that
Yeah,
clearly. there.
Yes,
So,
yes.
but where'd you grow up? How'd you get in this business?
Well, I was born and raised in Louisiana on the Gulf Coast.
What town?
I was born in Sulphur, which is just west of Lake Charles.
Okay.
Grew up in Cameron, which is on the coast, down in the heart of the oil and gas industry on the coast, offshore oil and gas exploration and production. Went to school in Lafayette, also in Louisiana, in the heart of Cajun country. And was working there in oil and gas. And one day I kind of sat back and said, I was a computer science graduate, right? So I was doing software on some of the early Unix machines. And I kind of sat back one day and said, I really could do this anywhere. Where would I like to live? I do love Louisiana, but I was a scuba diver and loved to come to Florida for vacation. So it just sort of dawned on me that, well, if you like the vacation there, why not go try to get a job there?
Yeah.
So I guess it was 1986, mid 80s, right after Challenger. I got a job at McDonnell Douglas, doing shuttle payload checkout systems, and got into the space industry just before the return to flight of Discovery of STS-26 in, what was that, 87, 88? And I've really been in the space industry ever since.
Awesome. And you had a little career here with the, I want to put all my notes on that, by the
Uh-oh.
way. Yeah, uh-oh. Where did I put all my notes? On my desk over there, Selvin. Marty's on vacation today, and no, underneath my phone there. Got that pack of papers right there, I think, is what I'm looking for there. Yeah. My Wikipedia of what we're going to talk about today, the McDonnell Douglas Delta Clipper. And I'm sure some of you, like Tom Usiak watching today, and maybe Dave Stangy's watching. Dave's got his granddaughter who's watching today up in Michigan. We got people all over the world. We got Robert Laws up in Dundee, Scotland, enjoying your cocktail, aren't you, Robert, up there? And Cliff Watson was the Australian that watches every day. He's in America now.
Oh my goodness.
And John Borelli. We're going to have
Wow.
John Borelli from New York. He's here on the Space Coast. We'll probably have John on the show Friday. But we got dozens of regulars that watch our show today, and we'll give them all a shout out. But we're going to talk about a very unique chapter of space history that was brief and somewhat productive, and you're going to give us a good insight on it there. And we love Louisiana people, by the way. Terry White, I'm sure you know Terry,
Oh yeah.
is a Cajun, and just had in my office yesterday Mr. Jay Honeycutt, who's from Jenna up there. So now I'm no stranger to the boudin and the good old gumbo from there.
Crawfish and filet gumbo.
That's right. That's right. So here's a picture of you at our Shuttle Fest. up there, and the subject that we provided you're going to talk about today. What was your impression of our little shuttle fest?
No, enjoyed it. It was Mikey Haddad went over some of the more interesting payloads and space missions that we did back in the day.
Yeah,
I found that just fascinating, going through some of the details and all there's so much that goes on behind the scenes that the public just doesn't see at these space missions, even before launch and during the missions. And so talking to the people that are involved in that, it's just, at least to me anyway, it's just fascinating.
Yeah, everybody enjoyed the details of the astronomy missions, the two space labs that had their own anomalies to work out, and then they had the Ulysses and Galileo space probes that had the radioactive thermal generators that everyone was freaking out about, though pilot Mike McCulley of Galileo said it wouldn't even light a toaster up,
That's right.
in there. So,
but just the science behind going out of the plane of the ecliptic, using all the planet flybys, was just fascinating. I know a little bit about that kind of thing, but I just find it fascinating to listen to folks who are really smart in those kinds of science and engineering fields to explain how it really works and why you do those kinds of things.
Well, I was on the phone today with Ed Rezak, who trained all the astronauts on the Hubble telescope. Wow. And he's going to be part of our Shuttle Fest 4, which is going to be Hubble plus 35. Today is the 34th anniversary of the Hubble being launched by STS-31.
The crew of the original deployment, or the
original deployment
mission
today. Yeah, led by I know who was the commander of that on there. Doesn't matter right now, but trying to.
Yeah, I know one of the astronauts is on the repair mission. I'm trying to remember his name too.
Yes, right.
He flies jets.
Well, I got my shuttle scroll here just to make sure
Your shuttle scroll.
everybody. Yeah, this is my shuttle scroll that we have the missions on, and 34 was 31 was the launch. Shriver. I was trying to think of Shriver, and Bolden was his second flight as a pilot. Then he was a commander. Lawrence Shriver, great astronaut. Love to meet him. Steve Hawley, the late Bruce McCandless, and Kathy Sullivan was on that mission to deploy the Hubble. And they thought it'd last about 10 years.
Where do you put that away?
Yeah.
So who's on the repair mission?
Who's on repair mission? Which one?
The Hubble repair.
The first one? Story
Yes.
Musgrave was on that one. He was the lead astronaut Walker on that.
Yeah.
And I forget who else on there. Let's see. Where's the Hubble? Oh, Covey. Covey was the pilot. Bauer Sox.
Yeah, Sox.
Sox was the pilot. Covey was the commander. Musgrave, Hoffman, Kathy Thornton. I knew Kathy was on that. Akers and Nicolier was on that. And Kathy and Musgrave did the heavy work on that. So we're hoping to have some of these people on our Shuttle Fest 4. Already getting that lined up for y'all on there. So this is what we're going to do every year around April 12th to celebrate the shuttle era with people that did it. And it's worked out pretty good for us there. So before we go any farther, are you a Star Trek or a Star Wars guy?
Oh, goodness. Well, I love them both. My kids love the Star Wars. We have Star Wars, what do they call them? When you sit down and just do a whole afternoon or a whole evening of Star Wars binge watching.
Oh, yeah.
But personally, I'm a Star Trek fan.
Okay.
Yeah, going back to the original series.
Yeah, I kind of like that myself there. And thank you. Move that picture down there a little bit if you can, Selvin.
Oh, goodness.
Recenter that. Working with Mr. Honeycutt yesterday, he sent me this on an email where it says, Spock says, "What do you know about atoms?" And Captain Kirk says, "Very little." And Spock says, "Besides that." Okay, so we get our day started off here right, okay? Because we're going to talk about this. On the left is the famous DCX, the experimental Delta Clipper, and I'm just going to kind of turn you loose about it. Here's the order that we put the pictures in there. But in early 1990s, this was a 1/3 scale of what they wanted to do. This was the baby of Douglas, McDonnell Douglas. They liked the DC because it drew a connection to the Douglas DC series of airliners, beginning with the DC-1 on there. So, Kevin, just sort of tell us a little bit about this program, how you got involved in it. Here's the, of course, I've got there, you got this 30 years later, we have seen over, how many they brought back? First stages, 300?
Yeah, quite a few.
I think
I lost count
I think
around
they
4.
hit 300 first stages they brought back. And it's beautiful to see them all sooty and out there as you're enjoying a meal at Port Canaveral at one of those fine restaurants.
Brings me back to my oil and gas days.
Yeah,
That's what it looks like. That's what it looks like everywhere.
Yeah, it does. It does. And then, of course, the Starship there that is basically the same idea. Even Elon Musk gave a shout out to this program, saying that his Falcon 9 development was continuing the great work of the DCX project. He actually said that, so he acknowledges it. Lots of engineers from Blue Origin, SpaceX were hired out of this program, and you cut your teeth on it too, apparently. So tell us a little bit about that, starting with the image you provided of the logo.
Well, let me start by saying that I had a rather small role. I was by no means one of the key people. I worked with a lot of key people that were just fantastic. The whole idea was really the brainchild of people like Jess Bonnable and others over at what was called the Strategic Defense Initiative Organization, or SDIO at the time.
Yes.
Which eventually became Missile Defense Agency today, through a few different instantiations. But the real leaders were some of the McDonnell Douglas directors. Of course, Pete Conrad was the commander or the pilot. My role.
No, this was not crewed vehicle, but he was.
That's right. That's right.
Pilot, so to speak, in the control room.
Right. Exactly. So the idea was to have a single stage to orbit rocket. In other words, a rocket that doesn't have to drop stages as it goes up, which is a tremendously difficult physics problem. Right. We won't get into a lot of the details, because I'm certainly no expert as well. But if you know the rocket equation, you know that it's you pretty much have to have 95% of your vehicle weight has to be fuel, just to overcome the physics of that situation. And that means all of your engines and your avionics and your aeroshell and your payload and your people have to make up like 5% of your total mass, and everything. So it all has to be very, very light, which is difficult because it's a very unforgiving environment. But anyway, the single stage rocket technology program was about exploring the technologies that would be used in that type of a vehicle. You couldn't bring you didn't have room or mass for landing gear, so if you're going to come back with people and payload, you have to land vertically. So it was a vertical takeoff, vertical landing VTVL vehicle, and the aeroshell, I mean, the shape of the rocket, as you can see, is fairly straightforward. It's pyramidal shape, which is just the most efficient way to develop and manufacture something that's going to take off and land vertically with a payload. The technologies involved were different materials for the tanks, and different propulsion systems. Much of it was commercial off-the-shelf components. And the operations, which is where I was involved, was focused on airline-like operations concepts, which is why we called Pete the pilot.
Okay.
And Tom Ingersoll was the co-pilot. And they essentially flew the vehicle from the ground. We had a little trailer we called the Flight Operations Control Center.
Here we got a picture of that here.
Yeah, you got some pictures of it. Okay. And the folks that were involved in that part of it were really using software that had been developed for shuttle. McDonnell Douglas had the payload ground operations contract out at the Space Center at the time. And my team was part of a group that developed payload checkout systems. And the systems that we were developing were using what were at the time cutting edge software technology. And it was being used because the shuttle was looking to ramp up its launch cadence. And so the checkout systems had to be easily reconfigurable in between flights, because every payload on the shuttle was different, right?
Right.
Had different test parameters, had different test configurations, had to go use different automation scripts to run it through its paces before it actually launched. So the software we had developed was designed to be quickly reconfigurable for each payload. And it turned out that was a good match for what Pete and Tom were looking to do on DCX. They wanted something that was easy to configure and could be used for significant amounts of automation. So in addition to the technology component of the program for single stage, there is also an operations component around the idea of how do you fly one of these things with just 3 people in the control room, rather than what did we have, 40 in the firing room for shuttle, and then another 50 in mission control in Houston. How do you get that down to an airplane cockpit? And just a pilot, a co-pilot, and a flight engineer. So there was a lot of work done around how exactly do you do that? Well, obviously you're going to need a lot of automation because 3 people can't manually monitor and control all the complexities that are on board a vehicle like that. So we used this software that had been developed for shuttle and NASA with their permission, and adapted it to DCX. And that is what Pete and Tom used to test and fly the DCX.
What attracted Moonwalker Pete Conrad to this? Do you know?
I think it was the whole idea around the simplified operations. It was a real challenge. How do you fly an orbital spacecraft up into orbit and down in the same way that you fly an airplane with just 3 people? That was a huge challenge.
And this was a serious attempt to do this. Let's look at a couple more pictures. Here's your, what are we looking at there? Just supplied that.
Yeah, so that's the rollout of the DCX, and essentially it's an 18-wheeler trailer, a tractor trailer, down on the lower right. That's the FOCC with the blue band around it. That was out in Huntington Beach, California.
We got better computer setup there, but that was your.
Yeah, so these pictures that I found, and I know I kind of shudder to think that Tom or Jess or one of the leaders of this program is watching, because I'd be quite humbled. They could talk it a whole lot better than I could. But these pictures that I got they're literally from 1993, 1994. So the resolution is just not what we're accustomed to. That's Pete Conrad sitting at his commander station in front of these 3 displays. That it's just kind of hard to tell what's on those displays, but what my team was developing were those types of displays and all the automation behind them. And Pete was in charge of saying, all right, if I'm going to do this, I need to be able to see X, Y, Z, and I need to see these certain parameters on the screen, and I need them to flash a certain color, or I need them to do some kind of animation if the computer thinks something's going wrong. And so we spent months going through his ideas on how to configure the automation scripts and the displays to fly this thing in that way. Those are 2 folks from my team that were working on this.
30-year-old computers back then don't look like the ones today, do they?
Those are old Silicon Graphics computers. Those aren't computers. That's just the monitor.
The monitor.
The computer's down under the desk.
Right.
And almost as big as the monitor.
Yeah.
But that was cutting edge technology at the time. Let me tell you.
Absolutely.
Cutting edge stuff.
Is that Pete there at the left?
Yep, that's Pete in the flight suit, and Tom Ingersoll in the white T-shirt. That was the pilot and co-pilot.
Tom Ingersoll, where's his name familiar to us space geeks?
He is with he's done quite well. After this program, after he left McDonnell Douglas, he founded, I think with Pete, a company called Universal Space Network. That was one of the very early attempts to establish a worldwide network for internet support, both on the ground and in space. So long before Starlink the idea came along, Tom and his team were ahead of the game. They did quite well. I'm not exactly sure what happened to the company. I think he ended up selling it, and did quite well. He now, I believe, he works for a investment firm out in New York City, investing in other companies now. Those two guys are like super brilliant. I mean, just off the charts, intelligent individuals.
In 1999, we lost Pete. He was in a simple motorcycle mishap that ruptured his spleen, and because he was in kind of a rural place, the medical care wasn't good, and he died. And just a tragedy.
He would tell us some stories about his motorcycle riding that would curl your toes.
Oh, really?
What you'd expect from an astronaut
right,
like
exactly.
this,
Sure, yeah. Pete Conrad, always famous with his gap teeth there, okay, that is from his Gemini days, and he was the third man on the moon with his buddy Al Bean and Dick Gordon, the other trio of that. They were just inseparable friends. Did you ever see Gordon or Conrad show up? I mean, Bean show up at these?
He had some folks that have come by, but honestly, Marquette was 30 years ago.
I hear you. That's why I just thought this is a chapter of space history that we don't want to swept under the rug. This was, I remember watching this on like CNN and early days of cable news network that they would broadcast. I mean, you're like, oh my gosh, we're gonna have a real spaceship like in Destination Moon or
Right.
a Forbidden Planet that lands, takes off and lands on its fins, so to speak, and so forth. So here's a look at some of the hardware.
Yeah, so they went through multiple iterations. So DCX was the original. Let me make sure I get this right. I may or may not, so I apologize to anybody who knows better. DCX was the original SDIO program, and it went through several test flights, really just small hops, straight up, translate over several hundred meters, and then come back down. This is all out at White Sands Missile Range, by the way.
There were 8 flights of this, by the way, that I actually found a thing that had the 8 flights there that were done.
That's DCX.
Okay.
So after SDIO, I think SDI, there you can see where it went up and across. So DCX ended because as I recall it, the SDIO program was winding down, and NASA picked it up and they renamed it DCXA. So DCXA was another iteration of technologies for single stage. NASA wasn't quite so hip on doing the single stage. I think they, at the time, realized that the technology was really just nowhere near adequate for actually doing single stage. So they used it as a test article to test other types of technology, other materials. I think they replaced one of the propellant tanks, upgraded some of the avionics, and upgraded some of the engines, just to test new technologies for the different rockets. DCXA went through a series of flights as well.
The fuel people might want to know what was used. I would have guessed hypergolics, but it was liquid oxygen and hydrogen. The norm. Hydrogen is the fuel oxidizer for the
Right.
oxygen there. Had 4 engines. All right. They call it the RL10A-5.
Yeah, that was off the shelf. That's what.
And throttleable from 30% to 100%, and they could gimbal the engines.
That was important because we actually did maneuvers up in the atmosphere where towards, I think it was around flight 8 or 9 or something. It was towards the end, and we went up in the DCXA era, and I don't know if I have any pictures of it or not.
Yeah, I've got the up and down like you showed me there.
Right, but even those were the earlier flights. Later, the gimbal was important because we actually tilted over while it was flying, and it's assumed, as I recall, it assumed an orientation similar to what it would have had to been to re-enter the atmosphere, which is essentially heat shield first, right? And then it had to it went out, it had to do this, and it had to flip back over and then land like this. We actually did that, and it was successful. That required, a lot of attention and technology all working together.
That's not what you're talking about there, because it went higher and had to flip it over. But
that's an earlier, simpler
There's
flight.
one of the earlier, simpler things, but still groundbreaking at the time. There was no vehicle on the surface of the Earth that was doing this.
Right, vertical landing was was a you're going to do what
Yeah,
moment.
in there. They didn't have shock absorber landing gear, just sort of skids on the bottom, I think,
Right.
in there. Didn't
Right, and that's really what I think was an inspiration for what Falcon 9 does in terms of landing on land vertically,
Right.
and the quick turnaround. See that I think SpaceX. I'm talking for them, but it seems to me anyway that SpaceX realized that if you're going to turn this around quickly, you need to land. You need to reuse the components first of all, and you need to figure out how to quickly get them back to the launch site, so that you can refurbish, reload, and fly again. That's just at the heart of this whole concept of operating like an airline, right? So it's not just a technology. DCX was not just a technology demonstrator; it was also demonstrating this fast turnaround airline-like operability concept.
And why did it take, a couple decades? Well, let's first talk about the successes of this. How you being involved in it? What did it? What was the optimism? What was the each launch? Of course, took it to the next level. I read a few anomalies where a hatch blew out on one of it one time. It still landed.
Mm-hmm. There was a fire at one point that all of those damages were repaired, and none of that was surprising. If you're going to fly with those types of propellants, you're going to get the occasional fire. That's pretty dangerous stuff. But I guess the takeaways from the program, thinking back over the years, over the decades here, one was that the team itself was just phenomenal. Under Pete and Tom's leadership, we just had some amazing individuals. The team was deliberately kept small. This was not a typical government, thousands of people type program. It was probably less than 100 folks total. It's very small, and there because a lot of us were out at White Sands. Most of the work was done either Huntington Beach or at White Sands, and so the team formed a bit of a family type bond, and the working relationship was very strong. A lot of long hours and weekends and whatnot, but there was a lot of support across the team, and I think over time we all recognized the incredible potential of turning these kind of vehicles around quickly. If it can actually land back at the launch site, all you have to do is refuel, put the new payload on, reload any software or any other mission specific configuration, hardware and software, and fly again, right? So the idea that, hey, maybe we really can turn this around quickly, which is goes back to the original idea of the space shuttle, but recognizing that this approach could actually succeed, and I think that's what really excited everybody, is seeing it actually work. I think there was one demonstration where it was flown twice in a day. I think twice in 2 days, something like that.
The A version or the X version there?
Ooh, that I don't remember.
Let's see. They had flights of this first experimental started, as I put this graphic up there, started in August 18th, 1993, and there's a little flight log of the DCX there. So you went from 93 to 95, and pretty much were you dedicated to that during the whole time?
No, like I said, my role was not, I didn't have a huge role. I was just associated with the Flight Ops Control Center, and it was I was more involved at the beginning. The original proposal, I was involved in the proposal that was selected in Huntington Beach, and then I was involved later in the development program after it was already flying. So my main job was back on shuttle payloads back out here.
What was as we look at a launch and a landing there, I remember watching these when they had them on live, and quite exciting to see it. So why didn't it continue?
Oh, that's a good question. Well, on one of the flights, one of the challenges or risks associated with doing things quickly actually occurred. I forget which flight it was. I think it was like the 9th or 10th. During the pre-flight checks, one of the hydraulic lines connected to the four landing gear legs, was mistakenly not reconnected. It had to be disconnected to manually exercise the legs and push them up, and after it was there, it had to be reconnected. One of them was not reconnected, and so when it landed, that one of the four legs did not come down, and so it landed and it fell over on its side. Falling on its side was really not that big of a deal. We could have recovered from that, but the propellants leaked out, and the hydrogen caught fire, and that was the end of the vehicle.
So you just had one test vehicle.
Yeah, and it was under NASA. That was the DCX-A. That was under NASA's program, and NASA was ready to move on. The next big piece of the story was a program that NASA called X-33.
Yes. Okay.
Right, and it happened about the same time.
Which was a Boeing project, was it not?
Well, it was a competition. So there was I was part of that proposal team as well. Huge proposal. NASA truly wanted to see if, based on what we had found, could we do single stage? How close could we get to single stage with more modern technology? This must have been 95, 96 timeframe. And so Lockheed did a proposal and McDonnell Douglas did a proposal. McDonnell Douglas's proposal, X-33, was essentially a souped up, larger version of the Delta Clipper. Lockheed Martin's proposal was what we call a lifting body, which is shuttle-like, but it doesn't have wings. The actual lift is achieved through the actual geometry of the vehicle itself. So it's a bit of a wedge. Think of the B-2 bomber type shape.
Like a triangular body.
And the whole body was a lifting body, so it didn't need external wings. NASA picked the Lockheed Martin proposal over us, so we lost and we went back to the shuttle. And unfortunately, Lockheed's vehicle was called the Venture Star, and unfortunately, during its manufacture, they just could not figure out how to manufacture the lifting body geometry with composite materials at the time. It kept delaminating, and they eventually canceled it.
Yeah, we've got a big model of that X-33 in storage there. Yeah, because quite futuristic looking, and another concept that just fell by the wayside. I guess that's research and development that you're involved in, right?
That's right.
What pieces and parts were taken away from this that you see got used in the shuttle program or borrowed by SpaceX and others? What were any key elements there that were adapted?
Well, I think the main elements that we mentioned earlier was the reusability. So you bring it back and you reuse the same vehicle again and again, right? And then the idea of landing it back at the launch site, allowing you to turn it around quickly, I think is essential. It's the centerpiece of SpaceX's business concept.
Absolutely. Well, fascinating. Selvin, we have any questions out there from anybody watching today?
We did have a question from Stevie J. He wanted to know, the real question is why the bigs like ULA have not yet followed SpaceX and DCX's lead.
That's an excellent question.
Steve Yokums, he's up there. Steve saw you at Shuttle Fest. He was up in Lake County, Illinois.
Yeah, and I would agree. That is a good question. ULA, I can't speak for ULA and their decisions. They are developing a new rocket called Vulcan, as I'm sure all y'all know, and they are, as I understand it, architecting it so that it does support reusability in the future. I don't know that they're going to get reusability out of them the first few missions. My understanding is it could in the future be reusable. I don't think they're planning to return the first stage, at least not at first. But I think everyone recognizes that reusability is essential to a solid place in the market today.
Talking with Kevin Brown here, who was a systems engineer in the 1990s on the Delta Clipper, but he's a vice president of All Points, involved. What are your duties there today?
Well, today at All Points, we're developing a new line of business around spaceport infrastructure. We're calling it Space Prep, recognizing that there is a enormous increase in launch cadence and payloads and satellites and spacecraft that are going to space. And it turns out that in the U.S. we've got we've got lots of rockets, and we've got lots of places to build satellites. We've even got lots of launch pads here and in Florida. But what we don't have is the infrastructure that is needed to do that, all that behind the scenes pre-launch work that I mentioned a little bit earlier. So when your spacecraft gets to the launch site, whether it be in California, Florida, or Virginia, or Alaska, or wherever you're launching from, there's lots of things you have to do. You got to get it off the truck, right? You've got to handle it very carefully. You got to make sure nothing broke during the trip. Oftentimes you'll have to integrate different parts and do last minute configuration. You're gonna need to put fuel into it, because you can't fuel it at home, because you can't send a fueled spacecraft over the road. It's too dangerous. And probably more importantly, you want to test it, because at the launch site, before you load it onto the rocket, is the last chance you have to make sure your spacecraft is going to work before it goes to space. So you need facilities for that. You need clean rooms. You need lots of tools and equipment. You need commodities, different gases and fluids. For years, we've had plenty of facilities to do that kind of thing, because we weren't launching that many spacecraft into space every year. But we've gone from a dozen a year to literally hundreds, and will soon be thousands a year. And so all that infrastructure, all those facilities and transportation and fueling operations and support are inadequate today at all of our launch sites. So All Points, being a Florida company and having worked on the pre-launch operations for years, which is what, when you think about it, the Florida space industry largely does focus on the ground operation, right? We don't build rockets here, well, until recently.
Right.
We don't build satellites here. Most of that's done in Denver and California and in other places around the country. So what do we do in Florida? Well, we do the launch site operation. So several years ago, we sat back and said, we see this huge increase in cadence coming, but the spaceports here in Florida just aren't ready for it with all this with the support facilities. So we started developing a business plan, going into the capital markets to understand if there was an appetite for investing in a business that would create multi-user spacecraft processing facilities and other infrastructure. And it turned out there's a huge appetite for it. So the past couple of years, we've been developing the business plan. We've been talking to potential customers. We got a couple signed up. Talking to investors. We've got many investors that are interested in participating in the capitalization. We've talked to the Space Force and NASA, both of whom agree that this is a huge problem. It's a big bottleneck at the spaceport, so they want to see it solved. They have cooperated with us and provided access and assignments of land parcels at Kennedy Space Center, at Cape Canaveral Space Force Station, and close to assigning something out at Vandenberg. And we're now in the process of doing the environmental assessments of these land parcels. Anytime you build something new, particularly on federal property, you have to go through a rather extensive environmental assessment to be sure that there's no nasty chemicals in the ground and you're not going to impact the wildlife. And so we're spending a lot of money and time doing that carefully, being sure that there's not going to be any adverse environmental impacts of the plans. It's going to take a few more months to get through that process, at least on our first parcel, and then we'll be ready to start building.
Kevin, when you talked about this at Shuttle Fest on our future panel, something that you brought up that just makes common sense is office space and storage space. You need a couple garages. You need desks, a nice environment to have the administrative people that are going to be tagging along with Firefly, via Space, these other companies, right? That's part of the infrastructure that you're talking about that it's lacked out there.
That's exactly right. It's not just the garage and the clean rooms to process, but it's all the support facilities for. So
bathrooms, stuff like that. You got to have out
cafes,
there.
Cafeterias.
They got to eat,
Right.
So the caravan has to have everything with it.
Parking lot
out there. Yeah, parking space. And observing sites, so stuff like that for the VIPs that are investing in these things, so they can feel part of it.
We feel the roof of these facilities is going to be prime real estate.
Yes, yeah.
for a number of purposes. So yeah, we got a whole team that's led by some people a whole lot smarter than me that are developing the designs and the the facility layouts and how they're going to be positioned on each of these parcels.
These are not going to be small buildings. It's not a small facility
No.
either. I've seen your concepts of different things. You got quite a lot of acreage out there that you're, I guess, leasing from the government. Is that would be
Well,
the
once-
way to put it?
Yeah, once we get through the environmental assessments,
Uh-huh.
assuming that they're all approved, then yeah, it will be a lease from the government for the
And
for the land.
of course, Merritt Island Wildlife Refuge is the neighbor of the Kennedy Space Center and Cape Canaveral, and environment's always been on the issue
Mhm.
of since the 1960s when all of this was created.
Yeah, it's important. So we're taking our time and being very, very, very careful about all the environmental work.
Also, as we ramp up for our Artemis program and other programs that are going to the moon and back, that's a big part of space prep too, right?
Absolutely.
Is the quarantine situations, both going to and from
Mhm.
another planetary body.
That's right. That's exactly right. There's the Artemis and the various components all have to be go through final assembly and preparation and testing at the launch site before they're loaded on SLS or a Falcon 9 or whatever their ride is. So we're in fairly advanced discussions with several of the organizations that are part of that program.
Well,
And you mentioned coming back as well. So that's another. We talk about launch. We seldomly talk about return and landing, but that's an important part of this. As space station brings things back, right? And the the International Space Station, particularly the National Lab, is going to continue for a few more years. But beyond ISS, NASA's planning to help sponsor some commercial space stations. There's a new vehicle that Sierra Space is developing called the Dream Chaser that is going to, as part of the resupply contract along with Boeing and SpaceX. Their Dream Chaser is similar to a Venture Star. It's a mini shuttle, mini lifting body that's going to launch on a Vulcan and probably other vehicles, and will service these space stations, bringing supplies, experiments, equipment up to these space stations, and then bringing them back. It will land on the old shuttle landing facility, Space Florida's new launch and landing facility, and then be turned around with new payloads and new equipment and launch again. So landing is an important part of this as well as launch.
one of the countries we've talked about, Kevin, on Stay Curious, that is at the forefront of that is Axiom. Axiom's done 3 private space flights now to the International Space Station, and they're going to build a mini space station that's going to break off of the space station, and our grandkids can take a vacation up there maybe when we start having it.
That's the vision. That is indeed the vision.
Yeah.
Axiom. I think there's a couple of others. Blue Origin has a contract for that, and
Yeah.
NanoRacks Voyager have a contract too.
NanoRacks Voyager. Okay, I think I've seen that name, but haven't dove into that. Blue Origin, of course, their Blue Reef, I think is what they're called.
Orbital Reef.
Orbital Reef. And I've just lived here 7 years, but I have seen the campus of Blue Origin go from
It's
the
enormous.
first bulldozers to, can you believe it, type of thing.
Right. And they're still expanding.
Yeah. But they're going to actually build the space stations and things right there across from Kennedy Space Center Visitors Complex.
Yeah, and their launch pad is coming along well. They're looking to launch this year.
And that is to launch what?
I believe it's the New Glenn.
Yeah,
they're,
the New
they're
Glenn rocket.
they're a huge rocket.
Huge rocket. And I keep telling people that, Kevin, they don't understand how big this New Glenn rocket is.
It is huge.
It's 350 feet tall.
Yep, it's like Saturn V.
220 feet for the Falcon 9 that we saw. Another one go up last night. Dogs were barking in the neighborhood and everything. But it's quite a sight to see. It doesn't get old to me. Watching another rocket go up to space like that.
I can't wait to see the New Glenn. That's
yeah,
gonna
the
be a
New
sight.
Glenn is going to be, it's going to make a big impact. It's just 1.5 miles from the the fabled lighthouse here, and I'm very involved with the Museums of Brevard, and the lighthouse is part of that. And
Sure.
and I've asked if they've done ground tests, out there, but they assure me that if it comes down, we're pretty sure Jeff Bezos will rebuild it for us. But it's been moved several times. Yeah, you got a comment, Selvin?
It's more of a question. Gary Jerriel wants to know where you see the future of the space industry.
Future of the space industry.
Yeah, that's a loaded question. Gary Gerald's out harvesting Vidalia onions
Oh,
in
nice.
Georgia right now.
Send me some.
Yeah, when he does come here with some, I'll call you up. But he's one of our other star. We just got 25, 30 people that watch this every day, and we're so grateful because they've taken us up to this level.
Wow, that's
And
awesome.
it's important to our museum. And so yeah, that's a question I had too. Is give us a landscape of what's going on. You're involved with one of the premier companies out there that's trying to make this multi-use spaceport work.
Well, I think of the future probably in 4 different arenas. So maybe take them one at a time.
Mm-hmm.
One is, I'll start with the military. This country is facing serious threats from our adversaries, our near peer adversaries. And I'm not going to get into the details. I'm not going to claim to be an expert on it, but we need to understand that our adversaries right now have the capability to take out our GPS systems. Right? They have the capability to take out our satellites. We need to have better, more resilience of our own orbit assets, and the Defense Department has recognized that and is now I'll say augmenting our existing capabilities with a much more proliferated architecture. So instead of having, I'll simplify it significantly. Instead of having 4 or 5 really big juicy targets, we're going to have hundreds, if not thousands. So it's a whole lot more difficult to take down the capability because it's more proliferated. That, because it requires so many spacecraft, is going to drive more demand on the ground infrastructure. So that's the military piece. The second is civil space. So NASA and the science community have not only the Artemis program, which is exploring the moon and then going on to Mars, but also the science community is interested in unlocking a lot of the secrets of God's universe, and have generally strong support across the country, for investing some of our tax dollars into that type of exploration. So between science and then human exploration to the moon and Mars is really where the future of civil is going to go. And what's interesting about it is NASA's recognized that they've recognized that we should be putting the largest portion of our tax dollars into development of capabilities that you might say are over the horizon. There's no point in NASA developing a new space station anymore. That's billions and billions of dollars. We've done it. We don't need to do it again. Let commercial industry do it, and NASA will just be a tenant, right? In the same way that NASA doesn't need to go build a minivan or a car. You just go buy one and use it, right? The same idea.
Great idea.
So let's use our tax dollars to build new capabilities further out over the horizon. Lunar, Mars, science. So the future in civil space is really about developing capabilities that today don't have a commercial business case. And which brings me to the third element, which is the commercial space. I think the future there is largely around communications and remote sensing. What's really fascinating is the lowering the cost of spacecraft themselves, through miniaturization and through the lowering of launch costs, has opened up just a plethora of new applications, of new things that you can do from space. I heard a couple weeks ago out in a conference in Colorado that there's some new sensors that have been developed that can detect, what did they say? They can detect methane from orbit. Well, why would you want to do that? Well, your oil and gas companies are very interested in finding leaks in their pipelines. And so they will pay. They're not going to build their own rocket and their own satellite, But they'll certainly subscribe to a data service that will flag any methane leaks that they can find in their pipelines, right?
Mm-hmm.
Farmers are interested in remote sensing of different, pests and irrigation shortages that are showing up that you can detect. Again, I'm not an expert, so it's hard to describe, but from space you can detect the different problems that farmers have with their fields, and the applications like that just go on and on and on. It wasn't it wasn't economically feasible to do that 20 years ago because it was just too expensive to put all that hardware into space. But today it's a lot cheaper to put those types of capabilities into space, and therefore earthbound users can take advantage of them at an economical price.
Mm-hmm.
Remote sensing, commercial. There's also increased interest in position, navigation, and timing, which is really what the government has done in the past with GPS. But it turns out that there's a commercial demand for it as well. So commercial has a lot of new applications that are, I think, part of the future. And the fourth area is the ground. I think the future space industry is also going to see a lot of new spaceports. There certainly are a lot of organizations around the country interested in developing spaceports. I don't know that all of them will come to fruition. But if you look far enough into the future, I think we'll actually see multiple space bases and potentially even point-to-point transportation around the world. The military is looking at doing point-to-point cargo delivery, but eventually I think if you want to take instead of taking a 12-hour flight from here to Tokyo, perhaps you take go up into low Earth orbit, or maybe just in a suborbital hop, and you get from New York to Tokyo in less than an hour.
Yes. This is where the Starship has piqued a lot of interest, particularly in the Defense Department,
Yes.
to deploy troops in a half an orbit away.
That's right.
In 50 minutes or something like that. It's accelerated quite at a big race.
That's actually a good example of showing where these four different swim lanes intersect.
Uh-huh.
It's a commercial company looking to build the Starship.
Yeah.
They will use different spaceports to launch and land.
Yeah.
And there's military utility to it, right?
Great.
I think the future is really the integration and the cross-pollination of these different aspects.
Great points by Kevin Brown there. Good question there, and I've enjoyed talking to you about this. It's you always wonder. Everyone says, "Well, what are these guys up to? What are they doing?"
Sure.
And do they really know what they're doing, or are they just putting it out there and knowing that it'll find its own level of use?
Sure.
Out there.
Yeah, we're certainly excited about it. There's lots of pieces you need. There's lots of companies building new launch vehicles. There's even more companies building different types of satellites and sensors and payloads and on orbit capabilities, and then many companies that are involved on the ground segment, both for launch and for operations.
Do you think a Blue Origin is interested in putting commercial factories for pharmaceuticals or other things that have been proven to work better in microgravity?
Sure, I didn't mention pharmaceuticals, but that's another really good example. For Blue Origin in particular, just like any other business, I think they'd be interested in anything that's has a business case associated with it, and that is within the scope of their company mission. But pharmaceuticals that can be, and not just pharmaceuticals, it's really across the medical industry. You've probably heard that you can 3D print human tissue in microgravity. I believe there was an experiment on space station where a meniscus was somehow produced, I think, with 3D printing.
Wow.
On space station. Which you can't do that on Earth because the tissue will, as you print it, it will just collapse.
Uh-huh.
But in microgravity, you can print it and it stays where you printed it, right?
Yeah.
So you can do this, and then when it's done, you somehow lift it out of the printer and carefully bring it back down to.
Just amazing. How far have we come? Well, Kevin brought in his own personal copy of a DCX launch out there. DCX Flight 8, July 7th, 1995. So
Do you recognize what that is?
Yeah. Yes, that is a VCR piece of tape there that I just threw away a couple bins of them.
Is that right?
Yeah.
We got a whole cabinet full of these things.
That weren't family oriented stuff. But yeah, we've come a long way. This was, and when Kevin handed me this, he goes, "Remember Blockbuster?" I go, "Well, I suppose anyone under 30 doesn't know what Blockbuster is, or certainly under 20." But boy, you went to the videotape store there, and Blockbuster even sponsored football bowls and everything in there, and it's all kind of it's all changed. I mean, I remember this has been replaced with like a thumb drive, and boy, I didn't trust thumb drives for a long time to, be secure, and it took me a while to trust the cloud.
And now you just stream it over Wi-Fi.
And now stream it over Wi-Fi, and the whole program you saw today's up in the cloud. So, Kevin, just really enjoyed talking to you about this. Give us a picture of how much things have really changed in the last decade out there at Kennedy Space Center and Cape Canaveral as far as the usage.
Oh, that's a good question. So Kennedy in particular is really transformed into a multi-user spaceport. 10, 20 years ago, it was shuttle, and then the few vehicles.
4 or 5 launches a year if you were lucky.
Right, and there really wasn't any other program. Well, there was the space station was out there and being processed through the space station processing facility. But today, the activity, as you said, Blue Origin has an enormous campus. SpaceX is building yet another campus. Another picture I should have sent you is a picture showing the launch pad allocations from about 10 years ago. I think there are 5 were in use. Today, the Space Force and NASA have allocated almost every single old launch pad to somebody. I think there's something like almost 20 have now allocated to some user.
Which ironically was our defense system back in the 50s, Missile Row, that those missiles, mostly Atlas, and were pointed at our evil adversaries out there. So forth. And it's gotten so busy that NASA is going to require, or I'm not sure if that's the right word, but if you launch from that pad, they want you to return to that pad. Now we got the landing zone 1 and 2, where the Falcon 9's landing, but that is going to be taken over by Via Space, and another company are going to lease it for their rockets.
That's right.
So they're going to lose that pad, and they want them to bring them back to where they took off.
Yeah, I believe it's the Space Force. It's not NASA that's imposing that requirement.
Okay.
That's because they want to
that
allocate.
Would make sense.
They want to allocate the real estate to as many different users as they can.
Yeah.
Many of those pads are, let's just say, they're fixer-uppers.
Yeah. Well, they're just a flat pad now. They got rid of all the infrastructure.
Oh no, most of them still have the old. It's all rusted and corroded.
Oh, do they?
Oh yeah.
So,
It's
a lot of fixer-uppers.
It's a major. Some of those are major fixer-uppers. But hey, it's prime real estate. Anything can be refurbished, and that's what a lot of these companies are doing now.
And quite an era we're living in here on the Florida Space Coast, where about every 3 days we're watching a SpaceX rocket launch. And though I may poo-poo it a little bit by saying it wakes up dogs and so forth, we have seen the fruition of this already. These Starlink satellites are providing internet and Wi-Fi and whatever service to some very remote areas of Earth.
That's indeed the case. Some of my colleagues have Starlink terminals at their homes.
Is that right?
And some are at their camps, and
And they like how they work.
Yeah, they say it works very reliably.
Yeah, instead of the old dish, big umbrella dishes that we had, they just throw out their own little dish there.
So. Or the old AOL dial-up.
Yeah, the old AOL dial-up.
You have mail.
That's right. Selvin, we have any other questions or friends over there to give us a shout out?
Carlton.
Okay.
Carlton Daly just made a comment that they make VHS to DVD recorded quite affordable, not for encrypted or copyrighted material.
Okay. All right. Good. Well, thank you for a great program. This hour flipped by real quick there.
Indeed.
But you're a very good you explain things very well, and I'm enjoying getting to know you. And we're certainly going to see more people from all points in space prep on this program. As Stephanie Sherby, hi Stephanie's one of our board members, and she's working her tail off for you guys. I know.
She is indeed.
And
We appreciate what you do at the American Space Museum. I think it's an essential part of our community, and we support you.
well, thank you very much. Well, we need that support. We appreciate the support from everybody as we take our museum really to a level that we never envisioned. Being involved with the community like this, bringing people like you in that can share their personal stories and inspire the other people out there. So, what haven't I asked you that you'd like to share with everybody out there, Kevin Brown?
I'm sorry, say again.
I said, what have I not asked you
Oh,
that you would like to share, or a parting shot here for our space loving community out there?
well, I guess you've covered most of the ground. I will say the way I think of space and space exploration, why, in terms of why it's important, is all the applications and things are important. We talked about, but what I think the really bottom line is, God created this universe, and I think He put a whole lot of things out there for us to discover, and that's the reason I support space exploration. I think there's a lot of treasures out there, and if we don't go explore, we're not going to find them, and that's what that's what I think what God's done for us.
And I'm with you 100% there, that this is the more we know about the universe, the less we understand it in ways. But as we expand and be open-minded, it all will crystallize in front of us, I think. I think we'll have a point of clarity one day that we'll never thought about, as the Webb telescope is making discoveries that challenge some of the ways of astrophysics thinking. But an astronomer friend of mine, Eric Perlman, that you saw talk at Shuttle Fest, it's because we don't know exactly what we're looking at that we just have. It's all part of the grand scheme.
That's right.
And as we learn more and fit the pieces in there, it'll all make sense one day. So.
We might find a compound on Jupiter, one of Jupiter's moons, that cures cancer. Right?
Absolutely.
I think those things are out there.
Could be waiting for us there. So, Kevin, thank you a lot for spending your time to come here and in our humble little museum and enlighten our program here with the DCX program there. Thank you for reminding us about the old videotapes down there. And we look forward to having you on in the future. And good luck to you and all points in space prep. So, anything to button up over there, Selvin?
Good.
Well, thank you for a good job today. We've got our good friend John Borelli's running around Space Coast. He's from New York, and he's just on fire to warm up his bones down here in Florida, but see a launch or two. We're going to have John on the show. We've had him on before, hopefully on Friday. And Thursday, we'll cook up some more Stay Curious about the shuttles of the month of April. After all, 16 shuttles launched in the month of April, and today was the launch 34 years ago of the Hubble telescope, one of the greatest inventions of mankind, without a doubt. And for it to be in its 34th year and going is just amazing. With the Webb telescope, the cross-pollination of the data there was never imagined that they could get this type of science. And there's going to be thousands of doctorate degrees come out of these two telescopes in the future. So thanks again, Kevin. Thank you all for watching. Until next time, I'm Marquette saying I can't wait to see you in our museum to bridge the space between us.